Good morning, students. In last period, we have studied the kinematics of circular motion, where we have studied all the quantities which describes the circular motion, that is velocities and acceleration. Now, today we are going to study the dynamics of circular motion. So, what is dynamics? Dynamics is the branch of physics where we are studying the forces which are responsible for particular motion. So we know that velocity changes at every instant in circular motion. Change in velocity produces acceleration, and according to Newton's first law, unless and until the force is acting on the body cannot be accelerate. So let us study the forces which are responsible for circular motion. So one of that is centripetal force. Now centri means towards center, and centripetal means which is seeking towards the center, that is centripetal force. So to understand this centripetal force, consider a stone tied to a string. Wield the stone with your hand and set it in a horizontal circular motion. If we cut the stone at point A, see the diagram given. So consider that if we cut the stone at point A, what will happen? The stone will fly off along the tangential path AB, as it has a linear velocity tangential. But if we will not cut, the string will be in circular motion, that from point A, the stone will go towards the point C, and it will happen because from point A to C, the stone will experience an inward force. So due to this inward force, instead of going towards the B or towards the tangential path, it will turn from A to C, and this inward force is called as centripetal force. The force which acts along the radius and towards the center is called centripetal force, and its magnitude is, as according to Newton's second law, F is equal to m into A. Here the centripetal force is equal to m into centripetal acceleration. So in the last lecture we have studied the magnitude of centripetal acceleration. It is minus omega square r. So it is equal to m minus m omega square r, or minus mv square upon r. By substituting v is equal to r omega. Here the negative sign indicates that the direction of this force is towards the center. So in circular motion, resultant of all real forces is a centripetal force. Means resultant of all the real forces is acting towards the center, and all these forces, centripetal forces, are acting in such a way that the velocity is always maintained tangential. So they help you to trace a circular trajectory. Now the second force which is responsible for the circular motion is centrifugal force. To understand centrifugal force, consider yourself on merry-go-round. That in such a way that merry-go-round is rotating uniformly. If you close your eyes, you will feel that you are at rest. If you close your eyes, then only you will feel that you are at rest and you feel that you are at rest. But you are not at rest. Actually, you are in rotation motion or in circular motion. The merry-go-round is rotating. So, as you feel you are still, there must be a force which neutralizes the centripetal force which is acting on you and able you to perform circular motion. So this neutralized force should be equal to in magnitude with the centripetal force, and it should be directing in opposite direction. And such a force is called centrifugal force. This is a pseudo force. Actually, this force is not exist. You feel this force. So that's why we call it as pseudo force. Okay? And because it is away from the center, it is denoted by the positive sign. The magnitude of centrifugal force is as that of the centripetal force. Only it is directed in opposite direction, means away from the center. So centripetal force is towards the center and centrifugal force is away from the center. And equal and opposite forces makes the vector sum 0, and that's why the resultant force acting on you becomes 0 and you feel it's a still, or you feel there is a no force acting on you. And this centrifugal force is a pseudo force, keep in mind. So this force arises because of the accelerated frame of reference. Means if you will consider the motion in your frame of reference, which is accelerated frame of reference, as you are accelerated in a circular frame. So this centrifugal force arises due to accelerated frame of reference. But before set it into uniform circular motion, means before the merry-go-round reaches its uniform speed, you will experience outward pull also. Okay, means when there is acceleration, means it is not in the uniform speed, means from 0 to set it into uniform field, at that time initially you will experience the outward pull. Why? Because here the centrifugal force is greater than centripetal force. Means the force towards the center is less than the force away from the center. Means the vector sum of these two is greater in the outward direction. That's why you feel outward pull. So after knowing these centripetal and centrifugal forces, we can write the force equations in case of circular motion. So the first one we can write, that is the m omega square r. Means here it is positive, means centrifugal force plus sum of all real forces, means centripetal force. The vector sum of this is equal to 0. Then and then only the circular motion is possible. So for circular motion, the sum of centrifugal force and and centripetal force should be equal to 0, or there must be only a centripetal force acting. Okay? Then only circular motion is possible. So, do you understand the centripetal and centrifugal force? So, let us recall the difference between these two forces. Centripetal is acting towards the center, while centrifugal is acting away from the center. Magnitude of both the forces is same. Only the direction is opposite. Centripetal force arises due to inertial frame of reference, means where the Newton's laws are obeyed, and centrifugal force arises due to non-inertial frame of reference, where the Newton's laws are not obeyed. And centripetal force is a real force. It's a resultant real force, while centrifugal force is a pseudo force, arises due to acceleration of frame of reference. Okay, children. So, these are the two forces responsible for circular motion. So, due to these two forces, circular motion is possible. For that, first one, there must be a centripetal force, resultant centripetal force, or centripetal and centrifugal forces are acting, they must be equal and opposite. If centrifugal force is greater than centripetal force, then it will not be in uniform circular motion. You will feel the outward pull. Now, we'll go towards the applications of the uniform circular motion. So, the first one is vehicle along a horizontal circular track. Okay. So, we'll consider a vertical section of a car on a horizontal circular track of radius r. Now the forces acting on this car are, first one, its weight mg acting vertically downward. Second one, the normal reaction vertically upward. And this normal reaction balances the weight. Therefore, we can write the equation that normal reaction N is equal to mg. And the third force acting is the force of static friction between the road and the tires. So, friction helps the car from outward slipping or skidding. Frictional force is the resultant of all the real forces, which is centripetal force towards the center of a circular track. So, frictional force is a centripetal force here, as the frictional force is acting towards the center. If we consider the frame of reference attached to the vehicle, then it balances the centrifugal force. Frictional force balances centrifugal force. Then only the circular motion possible. Therefore, we can write the equation here. Static friction is equal to centrifugal force. Means centripetal force is equal to centrifugal force here. So, static friction is denoted by Fs. So, Fs is equal to mr omega square. That is centrifugal force, which is also written as mv square by r, where v is the linear velocity. So, Fs is equal to mv square by r. Let us call this as equation number Now from equation 1 and 2 we can write that Fs upon n is equal to Fs is equal to mv square upon r divided by m is mg, which is equal to mv square upon r into reciprocal of mg, that is 1 upon mg. Get cancelled, so here remains Fs upon n is equal to v square upon rg. So let us call this as equation number 3. So what is our equation number 3? Fs upon n is equal to v square upon rg. Now in this equation, n is the normal reaction which is constant, g gravitational constant, and also for a given circular track r is also constant. Therefore what we can say, that is frictional force is proportional to the speed. So as the speed increases, friction Fs is also increases. So but above certain limit, if we will increase the friction, this friction will cause damage to the tire and also causes slipping. So let us find the speed so that the car can be safely driven. So we know that Fs, that is maximum frictional force, is equal to mu s into m, where mu s is coefficient of static friction and n is normal reaction. So we can write by rearranging, that is Fs frictional force, maximum frictional force upon n is equal to mu s, coefficient of static friction. Comparing equation 3, we can write the same equation for maximum friction. When there is a maximum friction, the velocity will be also maximum. So we can write the same equation as Fs max upon n is equal to V max square upon Rg. Let us call this equation number 5. Now if you will consider equation number 4 and 5, the left hand sides are same. So we can equate the right hand sides. So we'll get V square max upon Rg is equal to mu x. So rearranging this, we'll get V square max is equal to mu s Rg. Taking square root on both the sides, we'll get V max is equal to under root mu s Rg. So this V max means maximum speed with which a car can be driven safely without slipping or without skidding and without any damage. So this is the formula for the maximum possible speed so that the car can be driven safely on horizontal circular track without skidding. So I hope you have understood the whole expression. Again you go through this expression through the textbook, and if you have any doubt, ask me. So today's your homework is obtain an expression for maximum speed so that the vehicle can be straightly driven on the horizontal curved road. And the second one is write the difference between centripetal and centrifugal force. Okay, bye.